Okay, this question is about salts. Ammonium nitrate solution is produced when ammonia gas reacts with nitric acid. Give the state symbol for the ammonium nitrate solution. So here's the thing. Now, for state symbols, you could only have solid, liquid, gas, or aqueous, okay? Those are the 4 different states that you're going to find. Now, here's the thing. Because it's telling you immediately the ammonium nitrate solution, okay, as soon as you see solution, that means that something has dissolved in a liquid, and that would automatically make an aqueous solution. So your symbol here is going to be AQ, okay? There we go, and that will be one easy mark. Now, if you write down aqueous, you won't get the marks. Okay, the reason why you won't get the mark even though you're technically right is because they're asking you for the symbol. Okay, this is not a symbol, this is a word. That there is your symbol, so you wouldn't get the mark if you write down aqueous. And this is the sort of thing that you want to get used to when you are writing your exams, when you're practicing exams. So you gotta make sure you are reading those mark schemes. Okay, now question number 2.2. What is the formula for nitric acid? Okay, again, let's use the process of elimination. This is a multiple choice, and it says very clearly, tick one box, okay? Don't start going crazy ticking so many boxes. You only need one. So let's go by the process of elimination. Hydrogen chloride. Now, definitely that's not the answer. There is no chlorine in nitric acid, okay? Now, HNO₃. I'm not sure about that one because it is an acid, so we will have H. Nitric sounds like nitrogen. O3, I'm not sure, so I'm gonna give it a weight on that one. H2SO4. I know there's gonna be H's because it's an acid. S is for sulfur, and that's nitric acid. So that definitely makes no sense over here. That is not one of my answers. Now, in this other one, we have NH4OH. Now, it is a matter between these two. Which one of those is my answer, okay? But naturally, it's gonna have to be this one here, okay? This is your nitric acid formula. Now, these are the 3 strong acids that you're gonna encounter in your GCSEs, so you need to make sure you know this by heart, okay? So that one there is going to be hydrochloric acid, that one's going to be your sulfuric acid, and that one's going to be your nitric acid. You need to remember this. Just like you know your times tables, you need to remember the formula for the 3 strong acids that you're going to encounter in your GCSEs. All right, so let's move on to question 2.3. Ammonia gas dissolves in water to produce ammonia solution. Ammonia solution contains hydroxide ions, okay? So right here, hydroxide ions is this. That is what a hydroxide ion is. It has a negative charge of -1. A student adds universal indicator to the solution of nitric acid and ammonia. What color is observed in each solution? Now, we know that nitric acid is an acid, and we know that all acids, or at least I expect you to know this by now, all acids have H plus ions. This is what makes something an acid, and this is what makes something an alkali. Okay, so if you want to make a quick note of that, hydroxide ions, alkali, H plus ions, acid. Okay, now if we look back over here into this question, notice that hydrochloric acid has hydrogen, nitric acid has hydrogen, sulfuric acid also has hydrogen, and when they react, when they are dissolved in water, those hydrogens break away from the chlorine, hydrogen breaks away from the NO3, hydrogen breaks away from the SO4, leaving floating H pluses all around the solution, and that is what makes something acidic. So the question is, what color is observed in each solution? Well, color in nitric acid, you can have an array, okay? You can have anything between red all the way to yellow. Okay, so you can go either any of those three will give you an answer. And when it comes to the ammonia solution, because it contains the alkali, you can have anything from blue to purple or violet. Any of those three will give you the mark in that question. Right, so let's move on to question 2.4. Question 2.4. The student gradually added nitric acid to ammonia solution. Okay, so ammonia solution, remember that this one here is an alkali, so that's going to be an OH, and he's gradually adding nitric acid, and we remember the nitric acid has H plus ions. Okay, so we have something that is alkali, and then you're adding acids little by little, gradually adding the acid. Okay, this is what's happening in the question. You gotta be careful because a lot of the answers are actually in the question themselves. Now, which row A, B, C, or D shows the change in the pH as nitric acid is added until excess? Okay, this here, excess, means that you added too much. You added over the necessary amount. So if you're going to go and buy a game and that game is 50 pounds and your parents are giving you 70 pounds, that means that they're giving you an excess money. They're giving you more than what you needed. And this is what excess means in this place over here. See, it says that the nitric acid was added until in excess. That means that there was so much nitric acid that you didn't even need it that much. Okay. Now, we know the ammonia solution is a hydroxide, so the pH has to be 8 and above. So that will be at the beginning. So it would definitely, again, this is a process of elimination. At the beginning, ammonia solution can never start with a 2 because anything below 6 is an acid. It cannot be 7 because 7 is neutral. Okay, it has to be either 10 or 10. And this is this is so easy because it has to be one of those two. Okay, now remember that when we add the H pluses to the OH, what you end up making is, oh, that's wrong, it should be an arrow, not an equal sign. It should end up making water. Okay, and water is neutral. Water will be 7. Okay, so in this case you would think, all right, cool, so it used to be hydroxide, so that will be a pH above 8, so that can be 10. That's all right. And because the hydrogen and the hydroxide join together to make water, and water is neutral, it must be 7. But here's the catch. Okay, they're telling you that they added nitric acid in excess, so that means that you added enough H plus ions to convert those OHs to water and then some. So that means that you ended up with water that has on top of it more acid added to it. So the pH wouldn't be 7, the pH would be below 7 because the nitric acid has been added in excess. Okay, so your actual answer here is going to be D. Right, so let's move to question 2.5. Calculate the percentage by mass of oxygen in ammonium nitrate NH4NO3. So ammonium nitrate is this. Okay, here's the relative atomic masses of the individual elements. The total relative formula mass of the whole thing is 80. You need to calculate the percentage by mass of oxygen only. Okay, now how am I going to do this? Okay, first of all, remember that when you are calculating a percentage, you put the smallest number at the top and the biggest number at the bottom so you can calculate your percentage. Okay, so I know that the total amount has to be 80 because that's the total amount of that. Okay, that's the big number. So I'm going to have 80 at the bottom, and at the top I'm only going to do oxygen. Okay, now oxygen has a relative atomic mass of 16, and in this molecule we have 1 nitrogen, we have 4 hydrogens, another nitrogen, what am I writing in? Another nitrogen, so that makes a total of 2, and here's the one that we're looking for, oxygen. There are 3 of them, so that would be 16 times 3. So we're going to do a 16 times 3, And just to be sure, I'm going to type it in the calculator, right? So 16 times 3, 48. Okay. So in total, this would be total oxygen relative atomic mass is 48. So because we are looking at by mass of oxygen, we are going to add the 48 at the top. Okay. And to calculate the percentage, we're going to times the whole thing by 100. So let's get this done. Now, very often you will tend to do 48 divided by 80 times 100, and that's going to give you 60. Okay, let's see. Now, my advice to you is to use that, because at times the calculators might get confused with bot mass or bit mass, and it does the calculation wrong and you end up with the wrong answer. So I'm going to do 48 over 80 equals times 100, and then I get 60. Luckily enough, this time it gives you the same answer, but very often when there is more than just something simple like that, you end up with the wrong information being calculated because you have entered it in the wrong way. Okay, so this would be here 60%. They're not asking us for specific decimal places or significant figures, so we can just write down 60 straight away. And from here, you will get 1 mark for making the calculation of the RAM, 1 mark for your working out, and 1 mark for your actual answer, to make a total of 3 marks. So let's go to question 2.6. So describe the method. Okay, so we're just describing, we're not explaining what is going to happen. We're describing is we're saying what we see. Okay, what will we see when the method gets done. Now it says investigate how the temperature changes. Okay, so this is what we're going to be measuring. We're going to measure how the temperature changes, and if it's something that we measure, this is going to be your dependent variable. How the temperature changes when different masses of ammonium nitrate are added or are dissolved in water. So the thing that you're changing is the different masses of ammonium nitrate. This here is going to be your independent variable, okay, and dissolves in water. Okay, so to make this a fair test, you're going to have to dissolve it in the same volume of water, not amount, in the same volume of water. So this is going to be one of your control variables. Right? Now remember that the temperature of the water is also going to be a control variable. And right, so let's get into it. How do we start? Now, you would only need to write this down 1 time, and then you can say repeat steps so and so a couple more times, and that will be you. Okay, so you don't have to write the whole thing over and over again. So let's go with something that we call the BUN technique. Okay, BUN, where B stands for box the command word. Okay, so there we have it. Our command word is going to be describe, so we are going to box describe, and this is just telling us the structure of this question. U stands for underline the information, and that we've done already. N stands for number of marks, and in this case we got 6 marks. Okay, so we're going to circle the number of marks, which is 6 marks. We're going to try and make sure we get this done in that specific way. Okay, so I'm going to give you the steps. We're going to write them down afterwards. Okay, so first of all, because we are looking at temperature changes, we're going to be measuring the temperature. So we need to ensure that the container that we're using is as much as insulated as possible. Okay, so we're going to use a polystyrene cup or a beaker that has been wrapped up in some sort of insulation. Okay, so using a measuring cylinder, measure 20 centimeter cubes of water and pour them into a polystyrene cup. Okay, that will be step number 1. Step number 2 will be measure the initial temperature of the water and record it. Then, using a balance, measure a certain amount of ammonium nitrate, and you can choose. You can go with 1 gram, 2 grams, 3 grams, whatever you want. I'm going to start with 1 gram. So using a balance, measure 1 gram of ammonium nitrate, then pour in the ammonium nitrate into the water. Immediately after, put the cap on the polystyrene cup and using a thermometer, measure the change in temperature until the temperature stops rising or decreasing, whatever happens. I believe normally this is an endothermic reaction, so the reaction is going to get colder, so you would stop recording the temperature once the temperature becomes stable. Okay, now after that, what you can do is repeat the whole experiment, the whole thing again, but this time add 2 grams of ammonium nitrate, then you do it again, you add 3 grams, and again you add 4 grams, and that way you can complete the whole experiment and you'll be able to monitor the temperature changes when you add different masses of ammonium nitrate. And an alternative way of doing it is to add 1 gram, measure the temperature until it stops rising, then you add another gram, measure the temperature until it stops rising, sorry, decreasing in this case, and then you do it one by one, 1 gram plus 1 gram plus 1 gram, and every time the temperature stops decreasing, you add the next gram. Okay, and you can do it that way as well. So I'm going to write them down and you can take notes as well. Okay, so there you have it. That is your final answer. So that will be 6 marks for question 2.6 in the 2019 Combined Science Chemistry paper 1. All right, so let's move on to question number 3. Right, so there you have it. Quick time revision. Like and subscribe, and I'll see you next time.